Right, let's get another round of startup pitches. This time it's energy for AI. A big thank you to everyone here right now. We have our next presenters. Delighted to have a team of experts on our jury panel for this track. As any questions arise, we kindly remind any jury members before asking the question to present themselves. And I remind the panelists, you have 3 minutes per pitch. I will interrupt if needed, sadly, sorry. And jury members have 2 minutes. Let's give a big round of applause for this first pitcher, Heike Zatterstrom, CCO of Boson Energy.
Hi, everyone. So I'm here to turn your waste into edge compute. Your cloud can run on a hyperscaler in Phoenix, but anything real time has to happen in your city, and there's no power in cities. Our grids are not built for new digital loads and other electrification, and grid upgrades can take decades. New York, as an example, we need 750 megawatt of distributed urban edge load by 2035. At the same time, we're wasting 100 terawatt hours of distributed edge compute potential to landfills in the EU alone. Just the 2 landfills in Madrid also emit twice the greenhouse gases of all traffic in Madrid. Boson Energy can solve both by converting non-recyclable waste into sovereign edge compute. Waste is always available, so we're always on. We co-locate behind the meter, we're cost competitive and clean, and we're 10x the profitability of incineration. So our standard unit takes 100 tons of waste from about 100,000 people. We co-locate with the AI, and we deliver 4 megawatt of DC effect and thermal cooling to further save energy. We can also deliver district heating and EV charging for heavy-duty vehicles. Now, this is firm, urban, native energy that runs all year, regardless of weather and season. Our core technology is at TRL78. That's our IP and also our battery limits. All downstream systems are commercially available from our global partners and ready to scale. Our founder has brought 2 tech startups, deep tech startups, from garage to exits to Siemens and Nalco. We're complementing these entrepreneur founders with industry executives from Vinci and others. We have a global rollout partnership with Siemens. We are developing our first commercial project to bring the core tech to TRL9. Our first edge site, we expect to be live in 2029. We have a first close open of our rollout round later in the year. This open now. So this is unmatched impact. We can basically take a 15 million grid poor site and turn it into a 300 million waste to compute investment opportunity. New York can go from paying 500 million to get rid of its waste to generating tens of billions of sustainable economic value.
Sorry, I'm going to have to cut you off there. Thank you for your presentations.
Oh, yeah.
Any jury questions? One here.
Mayank from Carbon Direct Capital. Just curious, you mentioned Mayank from Carbon Direct Capital. You mentioned your gasifiers at TRL 7 or 8. Just kind of curious, like what you're seeing in terms of testing for efficiencies, tarring, heterogeneous feedstock, and how do you deal with that, and what do you get out the back end of it?
Yeah, so the technology is specifically designed to handle the variations of waste. The reactor package comes with a tar cracker, and the efficiencies are, the focus is carbon efficiency. So we have a high yield. So out of 100 tons of waste, we will get 10 tons of hydrogen gross. And then we have a parasitic load, so we can either take that from the grid or self-power, and then it goes down to 6 tons. Yeah.
Any other jury questions? If not, oh, there's one here.
Just wondering how much land, sorry, Andy Bradley from LCP Delta, how much land do you need for your unit? How much space do you need?
So this is half a football field, so which is an interesting surface compared to solar and wind, which will run into the thousands. Yeah, so particularly suitable for an urban setting. There's a lot of grid, less wasteland in urban areas, basically.
Any other questions? No. Thank you for your presentation. That was
Thank you.
brilliant. Next up, we have Eitam Friedman, co-founder and CEO of Carrar.
Hello. So, think about every battery project that we ever evaluated. A degradation curve that affects every model 2% a year, every year. This is what we call a standard. Maybe it's physics, but it's not. My name is Eitam Friedman. I'm Carrar CEO. For 30 years, the industry got better at managing the problem. Better cells, smarter softwares, larger systems, but the architecture would never change. So we kept building the same system, a system where heat builds up inside the cell, creating stress, drive degradation, and create safety risks. We managed the consequence, but we never managed the cause. We asked a different question, not how to manage the stress, but how to prevent it. We improved the physics. The liquid changes phase immediately as it's touching the cell surface, removing heat before it causing any stress. That changes everything. First, safety. The cell stays in constant thermal state. No path to thermal runaway. Second, lifetime. A cell that does not stress does not age the same way. The systems run 3 times longer. Same capex, 3 times the lifetime energy. A very different IRR. Third, a footprint, 30% smaller, better project density, more ways to deploy. And on top of that, our safety advantage gave us a path to a UL appendix, giving us a huge advantage over other competitors. That matters because certification does not open one market, it will open entire markets, different markets. This is not an incremental change, this is a total different asset class. The market is already moving. We have a 5-year contract project with automotive global OEM, partnership with Korean battery manufacturer, 2 active commercial BESS projects. We raised $15.5 million to date, and we are now scaling to commercial deployment by 2027. So every decade has a turning point, a moment when the industry stops managing the problem and someone solves it. This is the moment for the energy storage. The physics is solved, the market is ready. Be part of what comes next. Thank you. Right on time.
Thank you. Thank you for your presentation. Any jury questions? Any questions in general from the back? No? Well, thank you for your presentation. Big round of applause. Is Patrik Johansson here by any chance? No? Don't think so. Right, so we'll go next with Martyn Talbot, CTO and founder of Hydrohertz Limited.
Hello. Data centers are hitting a thermal wall when it comes to AI compute. This is due to the massive recent rise and demand in AI. It's costing operators millions, but it's entirely avoidable. Put this together with a 7-year wait for grid connection on new builds, and we've got a big problem. As well as that, we've got waste heat that's rejected as lukewarm as it runs through the system. So how can this change? The solution is the Hydrohertz Dectra valve, zonal control of the cooling system, where we optimize the entire system at shelf level. Currently, systems are cooled as one massive unit, whether it be room, whether it be the row, whether it be the rack. What we do is we take our Dectra valve, we put that into the rack, and we allow it to segment that rack down. That allows us optimizing of the cooling, saving energy throughout, obviously giving us waste heat utilization because we've got a higher grade on the return manifold, but it's a massive energy saver in general. So what does this mean to the operator? By saving that cooling power, we can have increased AI compute, more room for racks and servers. We can also significantly reduce CO2 whilst improving the PUE, and obviously a high grade waste heat, as mentioned, opening up a new revenue stream. Our team is built upon myself and an incredible couple of others there. Our backgrounds are engineering at the very core, from world leading automotive companies and engineering giants. This is where we are today. So we've got ongoing engagements with a number of automotive companies. We're at TRL 6 with independent validation, and we've recently gained a lot of interest globally in the media for our system on automotive vehicles. We've currently got an active raise at the minute, a seed raise for a £3 million investment. This will allow us to finalise our AI software, allow us pilot systems in live data centre areas, and obviously expand on our world-class team. That's me. I've kept it 3 minutes or under, I believe, there. This is Hydrohertz in a snapshot. Thank you.
Thank you, Martyn, for that presentation. Any jury questions? Right here.
To what extent do you have traction with the data center universe outside of the automotive?
So our traction at the minute with data centres is limited. We're pretty much new into the data centre area. We're making a bit of a transition from the EV side, where we've got validation, into data centres, because we believe from simulation that we've got, we can enhance the cooling system and obviously drop the power use.
I think there was another question here.
That was me. I had exactly the same question.
Oh, okay.
Yeah.
Question answered then.
Very early in the data centre scene.
Is there any other jury questions? The one there.
Curious. I mean, are there moving parts in the valve? Is it
So there is. It's one part, one moving part, and that valve that you've seen on the screen there allows 4 flow paths, independently controlled, each one from one moving part.
And how many hours have you operated one for?
So we've done that to automotive grade at the minute. So we'll have to convert technically to hours, but we've got it at 150,000 miles, well over 1 million revolutions.
Any other jury questions? No. Thank you, Martyn,
Thank
for
you.
your presentation. Next up, we have Doron Tamir, co-founder and CEO of Lawa Power. Oh.
Okay, so who will win the energy race for powering data center? Is it will be US, China, or maybe the EU? The problem in energy is this red line. This red line, it's called isentropic expansion. The meaning that the bubbles or the gas is expanding and doing the power, moving the pistons, moving the blades of the turbine, all the energy machines that you know based on this red line. Okay? The problem with this red line is the most inefficient way to have power, but this is the only way. What we succeed to do in lava is to move from the red line to the blue line. The blue line is called isothermal thermodynamic cycle, isothermal expansion, that the gas is expanding but not cooling down. It's not cooling down, so it's continue to expand. This is continue, this is the moment we move from the red line to the blue line. So now we can have everything in a 30% better efficiency. So what we're developing in lava, it's a new thermodynamic cycle. The first to be isothermal. And we have 2 machines. One is converting heat to electricity. This is our heat engine. We are best in converting heat to electricity and also best to converting electricity to heat and cooling. So the heat engine is to replacing ORC turbine and later on the steam turbine. The heat pump is to replace, is the best in cooling and heating. Just to understand the power of the thermodynamics, so if today we have 4,000 gigawatt of steam turbine worldwide, we know to generate from the same source of heat 5,200 gigawatt. The delta, the 1,200, it's double the US consumption for electricity. Okay? So I'm not saying that today we have 100 megawatt turbine. We start for a much smaller one, and we start with 10 megawatt turbines that will be ready end of next year. So, but for data center, what we can do? So we have the combination of the heat pump and the heat engine. It's called Carnot battery. Taking the electricity, generating heat, store the heat, and then generate electricity with the heat engine. We are not a small lab company, okay? This is just a picture of our new turbine, and we're just now signing agreement with a major utility in the US. They're going to give us 120 megawatt of solar, and we're going to convert it to 24/7 solar electricity. The meaning that we can actually power any data center with low cost, under 100 megawatt hour, to generate all the electricity the data center needs. Okay, so this is the Carnot battery, a very old concept that we are the first one to deploy it. Thank you very much.
Thank you very much, Doron. Are there any jury questions? One here.
I'm really sorry if this is probably a stupid one, but so what, you take solar electricity and then convert that into power. What is going on again?
We have the Carnot battery.
Yes.
The carbon, we're taking the solar electricity,
Okay.
generating heat,
Oh, I see. Okay. Sorry.
store the heat, and when we want to discharge, we're taking the heat using our heat engine.
And what temperature do you
120 dC.
And what about higher or lower? Is there a temperature band?
We can do with any kind of
Any-
temperature. In the end of the day, we know to achieve in the first phase for 70% of Carnot, later 80% of Carnot, but we don't have the time, but in Carnot battery, it doesn't matter if it's 120 or if it's 500. Okay, it's just the meaning of the COP of the heat pump and the heat engine. So it's like closed loop, okay? For us, it's much more good to go to 120 because then all the materials are very low cost.
Where are you in terms of customer conversations? And can you just remind us of, it sounds like you have was it a 5 megawatt coming next year? Is that your first commercial deployment?
Next year, we're going to be the first commercial for 10 megawatt. It will be for geothermal, okay? But the Carnot battery, the first one going to be ready end of 27. We are now signing the agreement with the utility, the tier 1 utility in the US. 120 megawatt solar that we're going to convert it to 20 megawatt, 24/7 solar electricity under $100 per megawatt hour.
Could you help us understand the round-trip efficiency of the process?
Yeah, for the Carnot battery, yeah?
Yes.
The Carnot battery is going to be 0.65, so 65%. If you will give us, for example, waste heat, so we can go up to 80, 90, yeah, it depends, because it's heat pump, okay? But basically it's 65 and for 30 years. We don't have any degradation. So if you will take, for example, lithium ion and go for 30 years, we are much of the same.
Perfect.
Perfect. Thank you.
Thank you, Doron, for the presentation.
Thank you.
Next up for the pitches, we have Vishoka Bala, co-founder of LoadCrest.
Perfect. You guys get the first pitch for the company. So, good afternoon, everybody. We are currently here because we are facing an unprecedented power demand that is being driven by AI. And we're stuck behind a $50 billion bottleneck in supply. The developers are ready to build, but the grid is just not able to do any of the interconnection work that's required. And the industry is not ready for the 800-volt transfer that is happening, driven by the hyperscalers. Enter LoadCrest. We take commercially available hardware and combine it with our proprietary control software to deliver the needs for the transition to 800-volt of the future. The financial impact is massive. Just like NVIDIA has claimed, we can save a 100-megawatt site nearly $90 million in 5-year TCO. And for the climate tech VCs in the room, this product is inherently driving decarbonization because you need less copper, you need less cooling, and most importantly, fewer DC to AC to DC conversions happening. So who's our target market? Our target market would be ideally all of the data center providers, but since we know, that we are going to be targeting neocloud providers and tier 2 and tier 3 data center providers who are building out 50 megawatt campuses and are currently locked out of the grid. The demand is real. We already got 500 megawatts in our first LOI pipeline, and we're in early stages for the next 500 megawatts as we speak. The business model is fairly direct. We were going to sell this for $500,000 per megawatt of capital and $20,000 per year in recurring revenue per megawatt would be for managing the site. This is not just a concept. The tech works. We've already completed all of the digital twin work with our vendor-provided data, and we've de-risked all of the AI-based workload interference that happens when it comes to running AI workloads at data center scale. So, in order to deliver against this, you need a unique set of skills. And that is exactly what the LoadCrest team brings. We have worked on utility-scale power systems. We've actually deployed for the US military, and we're just bringing this tech, working alongside Sandia National Labs, to this space. We've also worked in hardware acceleration and scale-up and in AI infrastructure. We will be opening a seed round in May for about $5 million, $4.8 million to be exact, and we're looking to work with climatic VCs, infrastructure funds, but most importantly, really corporate VCs who have this problem of not being able to connect to the grid, because our solution will help you get across the final hurdle. What we plan to use with the money, we plan to convert our proof of concept into a commercial market-ready solution for the future. Thank you so much.
Thank you, Vishoka, for that presentation.
Yes.
Any jury questions? Right here.
So admittedly, I'm a little new to the 800V ecosystem. I just hear it as a buzzword, but maybe you could just help me understand, because you mentioned these are for tier 2 or neoclouds who are unable to access the grid today.
Yeah.
How does this skip the grid or get them faster access specifically?
So most of the grid interconnection problem is not because of the unavailability of power. It's because of the subsynchronous and harmonics issues that happen with AI workloads. So essentially, when you have a 50 megawatt site just swinging on and off, the grid cannot be your shock absorber. And so that's the reason. So at the grid interconnection study, they just don't let you pass through. It's not because the power is not available. Because of our controls mechanism, we're able to completely distill, filter out all of the harmonics issues they run through today, and they can get connected to the grid. And I was going to say, most of the solutions include buying a bunch of StatComs, filtering, and buffering equipment. You can just completely remove all of that by just using our product.
Okay, so you mentioned a proprietary software and then
Yes.
off-the-shelf hardware.
Yes.
So is it basically one hardware installation with your software?
No, it's a 20-foot container which has DC-DC converters, inverters, a transformer, and our controller. And the controller is what we are really buying. The rest of the stuff we just pass through to the customer.
Any other questions? Thank you, Vishoka,
Thank you.
for that presentation. Next, we have Aric Saunders, Executive Vice President, Commercialization of Noon Energy.
This one?
Yeah, that one.
All right. Oh, Aric Saunders, EVP of Commercialization at Noon Energy. Noon Energy has developed a novel carbon-based energy storage system that provides ultra-long-duration energy storage, think 100-hour plus. And that is to solve the intermittency of renewables. That's what we were founded for. So Noon plus renewable energies is baseload power. We also can operate as a standalone asset and provide grid resiliency front of the meter or behind the meter. We can provide resiliency and transmission deferral. So a couple of things that are important. We focus on 100 plus hours. We are targeting $20 a kilowatt hour for CapEx. It's at scale in 2029, 2030 time period. We have no critical materials, so no rare earths and a 100% non-FEOC supply chain. We're also very energy dense because of the carbon-based nature of the system. We're 2 to 3 times more dense than lithium at scale, at the same, similar durations, and much more dense than other storage technologies. We can also provide 24/7, 365 hourly matching energy at prices that are at parity with fossil fuels in many places around the world. So we've built up a pretty healthy pipeline of over $6 billion, representing about 300 gigawatt hours of projects. Primarily, we have these 4 market segments, but the bulk of the traction today is in the hyperscaler and the remote grid. You think islands and islanded grids, so both make up the majority of our current pipeline. So we've deployed a system, a 100 kW system, 10 megawatt hours in California in partnership with California Energy Commission, and we've secured over 100 megawatts of supply chain of our critical components. So we were founded in 2018. We're raising our Series B right now, I'll get to in a minute, but in 27 and we'll have our first commercial project. 28 will be much larger, and then we'll be at large scale 100 megawatt plus type of projects in 2029. Team is really strong. Chris Grazer, CEO founder, came out of the Danish National Labs and actually used this core technology in collaboration with NASA for some work on Mars. So that's kind of the basis of where Noon came from. So we've raised $33 million to date. We're raising $65 million Series B right now to scale our manufacturing and supply chain to help us meet that demand. That's it.
Thank you, Aric, for your presentation. Any jury questions? Everyone here?
That's
So just technical characteristics of the battery in terms of time to charge, time to discharge, sea level, stuff like that.
Yeah, so
and efficiency as well.
Our technology is a reversible solid oxide fuel cell, and so we're using fuel cell, both electrolyzer and fuel cell mode. We actually charge 5 times faster than we discharge due to the voltage difference of a charge and discharge of a fuel cell. So yeah, we can charge up in 20 hours from empty versus that.
And like a response time?
Yeah, so we actually, our fuel cells are a little slower, so we actually integrate with a buffer battery to provide the full solution, so we can respond in 20 milliseconds.
Any other jury questions?
Yeah, so at scale, we're going to be in the 60 to 70% range. It is high temperature, 650 to 700 C.
Any more jury questions? Nope. Thank
good.
you, Aric, for
Thank
your
you.
presentation. And last but not least for this section, we have Joshua Benjamin, co-founder and network architect of Oriole Networks.
Hello. What a decade it has been. AI is making drastic improvements in every single sector. And as we have been seeing since this morning, there's so much effort and optimization everywhere to bring all of that energy to the data center. But have you ever wondered what is under the hood behind all of this? So what it actually is a bunch of GPUs that are connected with a network. And this network is currently the fundamental bottleneck. So we get all of this energy from all of these nice people, but it's not efficiently used currently. So every year the models grow, there's better models, there are better GPU chips to power those models, but there's a silent problem, which is the network itself. It's a very power-hungry, laggy network. And why is this a problem? Because developing this networking infrastructure is difficult. And this is where Oriole comes in. Our vision is to connect a large-scale network, AI system with a network that is so drastically different that it can reduce the power by less than half and give a very fast solution. Well, how do we do that? We use light. Prism is our pure photonic AI network, which is going to replace the laggy, power-hungry network with really fast connections between these GPUs. So this will completely connect any 2 GPUs in the network within nanoseconds, and it'll eliminate everything that's in the middle, so resulting in 0 cost for cooling and latencies and so on. So all the GPUs will then work effectively at full capacity all at once. So this is our solution. And we have huge benefits. We have power reductions that are 5x because we are able to radically transform the way the networking is done. So the way we do it is we give a holistic solution. So we take the networking problem from the physical layer and we engineer a solution for every single layer so that the optimization is seen at the system level. Now, I'm the co-founder of Oriole, and I have the privilege of working with people with great experience, and we've created a lot of noise. At the moment, it's inevitable that it's going to happen. It's definitely going to happen, but it's who's going to build it best and first. Now, that's the question. All right, thank you for listening.
Thank you, Joshua, for your presentation. Any jury questions? Want to hear it?
Yeah, just curious where you are in terms of deployment and what you've actually proven out till date.
Well, at the moment, so we've collected, we've been funded so far, seed and Series A, $50 million. At the moment, we're open for Series B. We're raising 150 million. At the moment, we have patents, about 20 of them, and we're still engineering. Our first product to market will be 2027, and we are shooting a moving target because the capacities are moving with every 6 months. There's a new technology to keep up with. So we have a roadmap that's aiming for 27, 29, and 32, supporting different capacities, and that's when our first products will come out.
Sorry to be selfish, but you mentioned on that quadrant you had Google in the same quadrant as you. I'm just curious like how you compare to Google in this offering.
It's not the same project as us. It's the way the solution is approached. Everyone else, there's a lot of photonic players, and a lot of industries are heading towards photonic solutions. But they give component upgradation. So they have transceiver modules that get better and better and better over time, right? But we look at the solution as to be a holistic one. So we give a system level solution. So we have pluggables, NIC cards, optics within those pluggables, and we have even within the team of 80 employees, we have people, GPU engineers, who check at the system level that the optimization is achieved in every single layer. So we give a holistic solution like Google.
Perfect. Thank you, Joshua, for your pitch and presentation. That wraps up this section of startup pitches. We now have a break until 5, so about just under half an hour until the next section, which is Climate Hardware X. We'll see you at 5 p.m.